Hello there. So in this video, we are going to discuss about the lifespan of the variable, and after that we will going to discuss about static variables. Now these two are very interesting concepts. So before discussing about static variables, let's quickly see what is a lifespan of a variable. Okay, so let's discuss about the lifespan. Now, when we say lifespan of a variable, that basically means for what term or for how much time variable actually exists in a memory. Okay, so lifespan of a variable is nothing but the time for which the variable is existing in the memory or it is residing in the memory. So let's quickly see on the whiteboard. So lifespan of a variable is nothing but the time or the difference between the times when the variable is created and when the variable gets destroyed. Okay, so it is nothing but the difference between the time when it is created and it is destroyed. So let's say if a variable, let's take an example of global variable. Let's try to understand what is the lifespan of a global variable. The global variable will have a lifespan equivalent to life of your program. Okay, I'm just repeating my statement. The global variable will have a lifespan equivalent to lifespan of your program. Okay, so whenever our program will get started or whenever our program will start its execution, at that particular time our global variables will get memory. Okay, and their memory will be destroyed or they will be removed out of the memory when the program will terminate. So that's why the lifespan of global variable is for the entire program. Now, what is the difference between lifespan and scope? So basically, scope tells us about the accessibility of the variable. So from which point to which point in a program we can access that variable. This is something which is defined by scope. But lifespan is different. Lifespan tells us about from which time to which time the variable exists in a memory. So let me just quickly give you an example. Let's go to the code editor. Okay, so let me just quickly type some code over here. So let's create one global variable. Let me just initialize it to 10. Okay, and before this global variable, let me just declare one function. So let me write void foo. Okay, and let me just call this function from main. All right, now in main, let me just write cout global. All right, and similarly, let me also write this cout global statement in foo function, which is another function, and we are calling this foo function from the main function. Cool. Now let's quickly see what happens. Okay, so see, we have a global variable with name global. Then we are declaring one function, that is foo function, which is just printing the global variable, and then we have main function which is calling foo function and then printing value of global variable. Now let's quickly see what we get as the output. So let me just write g++ followed by name of my file, that is 03 staticvars.cpp. Okay, cool. Now you can see that we are getting an error. What this error is telling us? The error is saying the global variable was not declared in this scope. Okay, where it is giving an error? It is giving an error on line number 6. Now why we are getting this error? See, the global variable, we are declaring it at line number 9. So its scope will start from line number 9. I will say it will start after line number 9 and it will exist till the end of the program, or it will exist till end of the file. Okay, it will exist till end of the program file. So this is scope. From which point to which point the variable is accessible, this is defined, or this can be identified by the scope. What is lifespan? Lifespan is from which time to which time the variable exists in a program. So lifespan of the global variable is for the entire program. So from beginning to end of the program, the global variable exists in a memory, but you cannot access it over here because its scope starts after its declaration. So I hope you will remember this difference. Lifespan is when the variable is introduced in the memory and when it is coming out of the memory or when it is getting destroyed. This is lifespan. Scope is from which point till which point you can access that variable. This is called as a scope. So these two are different concepts. All right. Cool. So let me just remove this global variable now. Let's now start discussing about local variables. Okay. So let me just remove this line as well. Okay, now what we'll do, I'll just declare one variable inside main. I'll name it as var1. Let me initialize it to 10. Similarly, let me declare one another variable in foo function as its local variable. Let me name it as var2. Okay. See, always remember, if you give these two variables same name, doesn't matter, because those two variables are in two different scopes, so they will not cause any conflict or anything, right? So you can create variable with same name in different scopes. Always remember this line. Okay, we are going to discuss about this thing in next video, which is FAQ video on scope. But right now, for our better understanding, I will just name this variable as var2, okay, so that there will be no confusion. And let me initialize it to 20. Cool, it's quite easy. Now what I will do, I will just perform few operations on var2. So let me write var2 is equal to var2 plus 20. Okay, that's it. So this is something which I am performing on var2. Now what I am doing here is I have var1. Let me also write cout statement. So let me write cout var2 followed by indl. And similarly, let me print var1 over here. Let me write cout var1. Okay, now let me call this foo function 2-3 times. Okay, so I'm calling this foo function 3 times. Now I am just interested in show you how exactly this program will execute and where exactly these variables will get memory, what will be their lifespan, and yes, so this is something which I want to explain you through this example or through this sample code. Now see, what is the scope of this var1 variable? See, this var1 is a local variable, so its scope will start after its declaration, it will end at the end of the program. So it will be accessible till this point or till this part of the program. Okay, similarly, what is the scope of var2? Scope of the var2 is for this much space. Okay, so let's quickly move to the whiteboard and let's see how this will work. Okay, so let me just go to the whiteboard. Cool. So we have discussed earlier that whenever we have functions and whenever we have local variables of the function, then the local variables of the function get storage in a memory called as stack. Okay, I hope you remember this. Okay, so in our RAM, whenever the program gets memory or whenever our program executes, it will get memory in a storage known as stack. So let me just rename this thing. Okay, just give me a moment. Yeah, so this memory is called as stack memory, and this stack will be responsible for giving storage or for storing our functions data. Okay, similarly, we also have another memory called as data. Okay, this is responsible for storage of global and static variables. Okay, so we are actually going to discuss about these two memories, so just give focus over here. So now how the memory gets allocated in the stack section, so let's quickly discuss that. So whenever any function executes, it will get a stack frame, and whatever variable that function has, they will get memory on that particular stack frame of that particular function. Okay, so let's first see how it will work. Initially the stack will be empty, then when the main function will execute, because that will be the first function that will be that will start its execution. So when the main function will start its execution, the stack frame for main function will be created. So let me just draw it over here. So this is nothing but a stack frame of main function. So let me just also write it over here. This is nothing but stack frame of main. Okay, so in main function you can see we have actually one variable, that is var1. Okay, so this var1 will get storage on stack frame of main. So this is nothing but my var1. Okay, this is my var1. You can see that var1 is having initial value as 10. Now after var1, after the var1 gets storage, what is happening? We are printing var1 on the screen, so this 10 will be printed on the screen. Then what is happening? We are calling foo function. So when foo function gets called, another stack frame will be created on top of the stack. That will be a stack frame of foo function. Okay, so this stack frame is a stack frame of foo function. So let me write it over here. So we have one more stack frame. Okay, cool. Now in this stack frame of foo, you can see in foo function we have a variable that is var2. So where this var2 will get memory? var2 will get memory on stack frame of that function in which it is declared. Okay, so it is declared in foo, so it will get memory on stack frame of foo. Okay, so now you can see here we have got memory for var2. So this is var2 and it is having initial value as 20. Okay, cool. So now we have var1 and var2 in our memory. You can see that var1 is present on stack frame of main and var2 is present on stack frame of foo function. Okay. Now in foo function what we are doing is we are incrementing var2 or we are adding 20 in var2. So what will be the updated value of var2? var2 is now 20, but now after incrementation or after adding 20 to it, it will become 40. Okay. So var2 will get updated and it will become 20. Then we are printing var2. So 40 will be displayed on the screen. Then what will happen? This function will terminate because it has executed its complete body. So this function will terminate, and as the function terminates, always remember this thing. I also told this thing while teaching you this topic in functions module. Always remember, when a function terminates, its stack frame will be removed from the stack, right? So whenever the function terminates, its stack frame will be removed out. So this will be removed from the stack, and then this var2 variable has been destroyed. So tell me, what is a lifespan of var2 variable? The var2 variable, or I will say in general, local variable of a function will have a lifespan from start of the function to end of the function. So it will get storage or it will introduced in the memory when the function starts its execution, or when function gets called, the memory for the variable gets allocated, and the memory for the variable is going to be destroyed when the function terminates. Okay, so what is the lifespan of local variable? The lifespan of a local variable is from execution, or it's for the complete execution of a function. So it's quite easy, right? Now let's see what will happen in the next iteration. So in next time what we are doing, we are calling foo again. So now what will happen? Again a fresh stack frame of foo will be created. This will be an entirely new stack frame. See, we don't have any context about the previous value of var, because in previous case we incremented var by 20, so var actually became 40, var2, okay, it became 40 in previous call. But now we don't have its context because the stack frame on which the variable was present is now destroyed. Okay, so now that var2 variable doesn't exist in a memory. Now when the next time when we call foo function, a fresh stack frame for foo gets created and var2 is again created, but again this will be a different variable. This will be not, or this will not have previous values. This will be a totally different variable. It will be again initialized to a value that is 20. Then when we add 20 to it, it will get value as 40. Okay, and then when we print var2, we'll get answer as 40. So for all these three calls, we will get answer as 40. Okay, for all these three calls, the answer is 40. Now what is issue over here? See, this is not an issue, but sometimes we may have this use case where we have to store context of a function, context of a previous execution of a function. In such cases, local variables are not enough. Okay, see, in previous case, let's say I have incremented value of var by 20 and var become not var, actually var2 become 40. Now next time when I will call foo function again, I want var to be incremented by 20, but the initial value of var2 I want it to be 40, because in previous call it became 40. So I want that context to persist. I want that value to be carried forward in the next function calls. Such thing cannot be achieved with local variables. You can see every time we call a function, local variable gets created. Every time a function terminates, local variable gets destroyed. So lifespan of a local variable is only for the execution of a function. They will be terminated at the end of the function. So this is the limitation with local variable. So we have another option, that is global variable. So what we can do is we can create a global variable. So let me just create this var2 as a global variable. Let me just initialize it over here. Okay, let me just remove this line from here. Okay, just a minute. Okay, cool. We have declared this var2 variable as a global variable. Now if you will execute this code, you will see that the output will change. Now the output will not be 40 40 40, rather it will be 40 60 and 80. Okay, so let me just change this output over here. It will be 40 60 and 80. Now why is it changing? Why the output is now 40 60 and 80? To explain you this, let's quickly go to the whiteboard and let's see what is happening right now and how this scenario is different than the previous one. Okay, so let's quickly go to the whiteboard. Okay, so now we are on the whiteboard. Now let's quickly see what is happening. See, in this program we have var2 variable, which is a global variable. Now we all know the global variables get memory in the space called as data space. Okay, not in stack space. And then we have stack space. So we have two different spaces, data space and this one is a stack. So on this space our global variables are going to get memory. Now this var2, the variable var2 is a global variable, so this var2 is going to get memory on data space, and that's the reason whenever we declare or when we use var2, it will be accessed, or the variable actually exists on the data and it doesn't get destroyed. Okay, it always remains till the end of the program, and that's the reason you can access global variables till the end of the program, and whatever value you put in them, it will persist, it will exist till the end of the code. Okay, so that's the reason what is happening whenever you are declaring var2 and whenever you are initializing it to 20, it is getting initialized with value 20. So this variable is initially getting value as 20. Then what is happening is from main function you are calling foo function. In foo, what you are doing is you are incrementing var, or you are adding 20 into the var initial value. So this var is now changing and now this var is becoming 40. Correct? And then when you are printing var, it is giving answer as 40. Now in the next call for foo, what is happening? Again var2, you are adding 20 to var2, but this time what is value of var2? This time the value of var2 is not 20, it is 40, because the previous value of var2 it still exists, or it is still present in the memory. Okay, so this is the difference between local variable and global variable, and that's the reason you are getting answer as 40, 60 and 80. So this is how the global variable works, and we already know that because we have discussed about the global variables in the previous videos, right? In this video, we have to discuss about the new type of variable or new category of the variable that is known as static variable. Now the static variables combines the advantages of global and local variable. Okay, so this static variable is kind of a new type of variable which is created by C++ creator, and it gives you the advantages of local plus global variable. Now let's quickly understand what is the advantage of global variable. The advantage of global variable is its lifespan exists for the entire program. Okay, so this is the advantage of global variable. So whenever you create a variable, it exists for the entire code. So whatever value you keep in that variable will persist till the end of the code. You can change anything in that variable. You can reassign new values to that variable. You can do anything in that variable till the end of the code. So this is the advantage of the global variable. What is the advantage of local variable? The advantage of local variable is local variable can be accessed only in that particular function. Okay, so if you are declaring 3 functions and the local variable of function 1 cannot be accessed from function 2 and function 3. So this is the advantage of local variable. So these two advantages are combined together, and then you have a new type of variable, that is a static variable. So static variable will have a lifespan for the entire program, This is one important thing about static variable. And the second important thing about the static variable is its scope is going to be limited for the area where you are defining it. Okay, so if you are defining it inside a function, then its scope will only exist for that particular function. If you are defining it inside a block, then its scope will be only limited to that particular block. Okay, so this is how the static variable works. This is high level information about the static variable. Now let's quickly get started in a program and let's see how we can create a static variable and how actually we can start using it. Okay, so now here this var2 is a global variable. Now instead of declaring it as a global variable, let me just remove it from here and let me put it in the function. And instead of declaring it as a normal local variable, so how we declare a normal local variable? We write data type followed by name of the variable, and then we do some assignment to it, or we assign some value to it, right? Instead of doing this, we want to declare this as a static variable now. And to declare any variable as a static variable, what you have to do, you just have to add static keyword before its declaration. It's very easy, it's super easy. So what you have to do, you just have to write static before this, and whoa, voila, this now becomes static variable and it gets all the property that we discussed so far. Let's quickly execute this code and let's see what we get as the output, and then we'll discuss about how things are working. Okay, so let's me quickly run this code. So let's write g++ followed by file name, that is 03 static var.cpp. Okay, cool, it has got compiled. Let's quickly execute this code. You can see that we are getting output as 40, 60 and 80. Okay, don't concentrate on line 1, I mean on this 10, because it is actually useless. So let me just remove these two lines, they are of no use right now. Cool, so you can see that we are getting output as 40, 60 and 80. Now this output basically means that the previous values which are getting stored in var2 variable are persistent. Okay, so they are getting stored properly, they are not getting destroyed after end of each and every function call. So this is how the static variable basically works. So let me quickly show you how this thing is working. See, we are declaring int var2 as static. So whenever you declare any variable as static, it will be declared, or it will get memory on the data frame or on data memory. It will not get memory on stack memory, it will get memory on data memory. Okay, and because it is getting memory on the data memory, it is not getting destroyed every time the function gets terminated. And that's the reason whenever you declare a variable as a static variable, it kind of acts like a combination of global and local variable. Okay, always remember there are few rules that we need to keep in mind about static variable. The first rule about static variable is it gets memory in the data section of the memory. Okay, so where it gets memory in data section of the memory. The second and very important rule about the static variable is it gets initialized only once. This rule is very important, just try to focus. See here, let's see what is happening. Here we are declaring a variable with name var2 and it is declared as static. Now we are initializing it to 20. Let's see what is happening. In the first call to foo, the variable will have value as 20 because it is getting initialized to 20. Then we are adding 20 plus 20. Okay, so now this 20 plus 20, that is 40, will get stored in var2. So var2 will become 40. And then we are printing 40 on the screen. So 40 will be printed. Now in the next call to foo, why the value is coming as 60? Why it is not coming as 40? Okay, why this var2 is not getting reinitialized? Because you are again calling foo function and this var2 is declared inside foo function. Its assignment is done over there. So why it is not getting reinitialized? Why it is not getting reassigned? The reason being the rule about static variable. What rule? Second rule of static variable says whenever you create a static variable, it gets initialized only once. Okay, so whatever initialization you are giving to the static variable, it will be done only once. So every time you call a function, it will not get initialized to 20, it will get initialized only once, and that's the reason we are getting output as 40, 60 and 80. So I hope you will keep this rule in mind, you will fix this in your mind. static variable gets initialized only once. Okay, so here we are initializing it to 20, but it gets initialized only once, and after the next call or subsequent calls it will not get reassigned to 20. Okay, so this is another important rule about the static variable. And the third and most important rule about static variable is static variable have scope limited to in which place you are declaring that variable. So if you declare a static variable inside a function, then its scope will be limited to the function. If you will declare it inside a block, let's say like this, see, let's just change the code. Let me just format this document. Okay, and let's quickly run this code. Okay, you can see or you can observe that we are getting the same output 40, 60, 80. Okay, so it is still acting like a global variable, but now what has changed? Its scope has changed. How it has changed? Now the scope of this var2 is limited to this block. You cannot access var2 outside of this block. Okay, so if you will try to access it over here, you can see editor itself has started giving us an error that var2 is undefined. Okay, so basically the static variable works very similar like local variable. Okay, so its scope will be limited to where you are declaring it. You are declaring inside a function or you are declaring it inside a block. All right, so this is basically how we use static variable. Now let's say I want to count how many number of times a particular function is getting called. Okay, so let's say I want to count how many times the foo function is getting called. So for that, what we can do is we can make use of static variable. Okay, so for that, let me do this. So I'm declaring a variable static int counter. Let's initialize it to 0, and then in each call we will increment this counter by 1. Okay, so we'll write counter plus plus in each step, and then in each step we'll just print value of counter. Cool. All right, and then let me just remove these comments. Cool. Now if I clear this, let's see what we get as the output. Okay, so if I clear this and if I run this, you can see that we are getting output as 1, 2, 3. Okay, so what is happening? The static variable is initially getting initialized to 0. Then in each step it is not re-initializing, or it is not getting re-initialized. Okay, because it is going to get initialized only once. Then in each step it is getting incremented by 1. So on first call the count will become 1 and 1 is getting printed. On second call it will become 2. On 100 call it will become 100. Okay, on 1000 call it will become 1000. So in this way the static variable basically works. Okay, so I hope you're very clear with the idea about the static variable. You enjoyed watching this video. You got all the concepts that we covered in this video, and see you in the next video. In the next video we are going to see FAQs on scoping and lifespan of a variable. Okay, so I'm going to cover few questions that usually my students have whenever they start learning about the scoping, or whenever they start thinking about scoping and lifespan of a variable. So see you in the next video.